हाँ जी बच्चों, टुडे वी विल डिस्कस a dual simplex method. What is the beauty of dual simplex method? We will start the problem uh, where we don't get the feasible solution. Basically, we'll start from the infeasible solution. Where we will apply this dual simplex method? Wherever any of the constraint is of greater than equals to type, means where we have applied big M method, two-phase method, method of plenties. So these are the method: big M method, two-phase method, method of plenties, H-Arness method. So we are going to apply this dual simplex method. Let us have the same problem which we discussed earlier. The problem was of minimization type. Minimum z is equal to x1 plus x2. If you recall, we are working on this problem. So far we have applied all the method. So today we will we'll solve the same problem with the dual simplex method. So what is there? 2x1 plus x2 greater than equals to 4, x1 plus 7x2 greater than equals to 7. So if you look at here, this problem, if you look at this problem, we'll convert this into the maximization type. This is maximum z dash is equal to minimum of z. What is there? Minus x1 minus x2, clear? And what I do here, same thing. Let us do it like this one: x1 plus x2 minus, rather convert this into the minimization type, because to convert it into the infeasible form, because the problem is of maximization type, convert into the minimization. Minus 2x1 minus x2 less than equals to minus 4, clear? So this is another one: x1 minus 7x2, multiply whole question by the minus sign, you will get the sign to be changed. So here, once you are converting into minus 2x1 minus x2 plus s1 is equal to minus 4, because this is less than this one on our right hand side. So similarly, if you look at here, minus x1 minus 7x2 plus s2 is equal to minus 7. Here you will add 0 times s1 plus 0 times s2, clear? Once you will similarly x1 comma x2 s1 s2 greater than equals to 0. Look at here, calculate IBFS. For calculating the IBFS, x1 is equal to x2 is equal to 0. You will guess s1 is minus 4, s2 is minus 7. This does not satisfy this one. So basically this is the infeasible solution. What is the beauty of this one? Dual simplex problem. We'll start from the infeasible solution. Let us start from the infeasible solution. Again, simplify it. We'll simplify it. Again, this we have already discussed couple of times: CSV, EI, X1, X2, S1, S2, B. From first constraint, we get the value of S1. This is Cj here, minus 1, 0, 0. Clear? So far, is it okay or not? So we have reached here. Let us do S1. It is having coefficient 0, S2 0. So substitute here: minus 2, minus 1, this is 1, this is 0, this is minus 4. Clear? Here it is minus 1, minus 7, 0, 1, minus 7. So it's, I think so far we are okay here. So out of that one, calculate EJ. When you are calculating EJ, multiply the corresponding element and add it. This practice we have already done. Now calculate Cj minus EJ. You got the coefficient minus 1, 0, 0. Clear? Here, if you look at here, what happened here? Choose, we are not going to calculate any theta here. Choose the most negative from a B part. This has been chosen. So you are calculating the ratios now. How to calculate the ratio? So basically it's Cj minus Ej divided by the corresponding row which has been chosen. Clear? And we will consider only the negative coefficients. So this we are not going to take. Why? Because there is a negative coefficient which are there. So basically this value is 1, this is 1 by 7. Which is least? This one is least. So this has been chosen. Clear? So 1 by 7 has been chosen. So this is the coefficient. This is the coefficient. This is the minus 7. So here outgoing variable is decided first, then the incoming variable. And this is the pivot element or the key element. Now again calculate x1, x2, s1, s2, b. So if you look at here, this is minus 7. It should be make now 1. For making it 1, what we have to do? X2 is coming inside, this is minus 1. So divide whole question by minus 7. So this is 1 by 7, this is 1, this is 0 here, this is minus 1 by 7. Clear? And here it is 1. Is it okay so far? Is it okay so far? So this is what we have calculated, 1 by 7, 1, 0, minus 1 by 7, 1. Now here we are going to make it 0. What we will add it. This is minus 13 by 7. Clear? This is 0 here. This is 1 here. This is minus 1 by 7. We add it. Clear? So here it is minus 4. This is minus 3. Is it okay? Minus 13 by 7, 0, 1, minus 1 by 7, minus 3. Now again calculate Cj here. Minus 1, 0, 0. So we are left with only one minus sign. So this has been chosen. So first of all calculate Ej. This is minus 1 by 7. This is 1, 0, this is plus 1 by 7. Clear? Cj, Ej minus calculate. Cj minus Ej. So minus plus, this is minus 6 by 7. Clear? So this is minus minus, this is minus 2. Here it is 0, this is minus 1 by 7. Minus 6 by 7, minus 2, 0, minus 1 by 7. Now again calculate ratio. Again calculate the ratio. Now we have already selected this one. So what is here? Cj minus Ej divided by minus 6 by 7 over minus 13 by 7. So we can't do the comparison because here it is minus, here it is 0. So basically here we can't do the comparison, here we can do the comparison. So if you look at here it is in minus 2 over 0. Clear? 0 over 1, but we should not consider this one. Even we should not consider this one. This can be ignored. Why? Because both are not the negative one. But here we can do minus 1 by 7 over minus 1 by 7. Clear? So here it is, you are getting 6 by 13. This has been chosen. The least one has been chosen. This is chosen. Clear? 6 by 13. This is 1 here. When you are comparing 6 by 13 and 1, so this 6 by 13 is minimum. So this has been chosen. Clear? So probably this will be the last step. CSV, EI, X1, X2, S1, S2. Clear? Here it is B there. Now what is there? S1 is going outside. What is coming? X1 is coming. This is having value minus 1. This is X2 minus 1. Make it 1. Multiply by minus 7 by 30. This is 1 here. This is here. This is 0. This is minus 7 by 13. This is minus minus plus 1 by 13. And here it is 21 by 13. Here it is 21 by 13. So what is here? Here it is 1 by 7. Here it is 1. Make it 0 here. This is 0 here. This is 1 here. Divide whole question by 7. When we have to divide whole question by 7 and subtract it. This is 1 by 13. Clear? So here it is minus 1 by 7. Here it is minus minus plus minus 1 over 91. 91 is LCM, minus 13 minus 1. This is minus 2 by 13. Clear? So here, if you look at here, this calculation has been done. So we are left with 1 minus 20, 1 by divide by 7, this is 3 by 13. This is to take 13 LCM, this is 13 minus 3. This is 10 by 13. Anybody having any doubt so far? Anybody having any doubt so far? I think we have calculated this one 7 by 13, 1 by 13, this is 1 by 13 minus 2 by 13. Okay, now here it is Cj minus 1, minus 1, 0, 0. If you calculate Ej, this is minus 1, this is minus 1. This is 7 by 13, this is minus 1 by 13, this is 6 by 13. Clear? This is 1 by 13, 2 by 13, the 1 by 13. Clear? So calculate, take the difference of Cj minus Cj, 0, 0, minus 6 by 13, minus 1 by 13. So the values here Cj minus Cj either are 0 or are negative. If the problem is of maximization, here the problem has been converted into a maximization. The original problem is of minimization time. So we got the optimal result. What is the optimal result? X1 is 21 by 13. This we have already calculated a couple of times. This is 10 by 13. What is Z minimum? Z minimum is nothing, basically 21 by 13 plus 10 by 13. This becomes 31 by 13. Again, this is your primal problem. What is the dual problem? Again, this we have already done couple of times. Dual problem. What is the dual problem? Dual problem was, I will look into the only the objective function, that is maximum W. What is that one? That is 4y1 plus 7y2. And this represents your y1 and y2 with a change sign. S1, S2, this represents your y1, y2 value. 4 into 6 by 13 plus 7 into 1 by 13. Basically, this is 31 by 13. Again, the duality theorem has been proved. The primal result gives us the 31 by 13, and the dual problem have also given the result of the 31 by 13. So what was there in a dual simplex? We started with the infeasible solution, and then we reached to the feasible solution. So if you have, where we can apply this two-phase this dual simplex, wherever any of one of the constraint is of greater than equals to type, means where we can apply the Bingham method of plenty, A-Charness, or the two-phase method. This is another possibility, the dual phase method. That's it from my side. Thank you very much.